This video is going to take us through the notes as well as the examples for the volume of spheres. So the objectives, and as I started this video I just noticed, the objectives are find the volume of spheres. So now these notes did appear in a prior set of notes for 11.1, but a sphere is the three-dimensional circle, the set of all points a given distance, the radius, from a given point, the center. A hemisphere is half of a sphere. So the volume of a sphere, and we're not going to go through the derivation of this, but the volume, it's written right here, is equal to 4/3 pi r cubed. A hemisphere is half of a sphere, so I just write it as the volume is equal to 1/2 times 4/3 pi r cubed. And hemispheres will come up sometimes with, Hemispheres will come up with the example we're going to do, which is a compound shape. So the we do is going to be a compound shape. The you do is a little more simple. It's just a sphere. So this looks like a cone with a hemisphere on top, or a cone with a scoop of ice cream on top. So the top here is a hemisphere. And the bottom is a cone. So I'm going to find the volume of the hemisphere and add the volume of the cone. So to find the volume of the hemisphere, I'm going to do volume is equal to 1/2 times 4/3 times pi r cubed, so times 3.14 times the radius here is 3 cubed. So now, using my calculator, just want to make sure you can see the buttons too. So I'm going to do 1/2 times 4/3 times, now to do the fraction bar I'm using the division symbol, times 3.14 times 3 cubed, I'm going to put the 3, and then to do the exponent, I'm going to do the caret symbol. Now I know the calculator has a square button, but it doesn't have a cubing, so I have to hit this, it's called the caret, hit that, and on my calculator it's going to push it up as an exponent, and a 3, and then hit enter. And I am getting the volume of the hemisphere as 56.52. 56.52. I'm going to have to now find the volume of the cone. Now this is from the last set of notes. Volume is equal to 1/3 base times height. And for the cone, I can draw the base. It is a circle. It's just a circle with a radius of 3. You can see it right there. So this is volume is equal to 1/3. The area of the base is going to be pi r squared. So 3.14 times 3 squared times the height of this cone. And to find the height of the cone, I have this is 3, I have this is 5. This is a right triangle. I can set up and use the Pythagorean Theorem. This is very similar to the opener, where I have the leg, this is the hypotenuse, and this is another leg. If I call this A, this B, this C, I can get A squared plus B squared equals C squared. 3 squared plus 3 squared plus b squared equals 5 squared. 9 plus b squared equals 25. Subtract 9 from both sides. B squared equals 16. Take the square root of both sides. B is equal to 4. So the height of this cone is 4. So this problem's a little bit involved in terms of finding everything that we need. So the volume, we now have all of the numbers, so I'm going to grab my calculator. It is 1/3 times 3.14 times 3 squared times 4. And I'm going to get 37.68 is the volume of the cone. So the volume total is equal to 56.52 plus 37.68. 56.52 plus 37.68. And the volume of this composite shape, meaning it is made up of 2 or more shapes, is 94.2. And it will be units cubed. Okay. So now, you can pause the video and try to find the volume of this sphere. Okay, hopefully you have tried to find the volume of the sphere on your own. So, it is a sphere, so the volume is equal to 4/3 pi r cubed. Now be careful here. You're not given r, you're given the diameter. So to find r, you're going to take that diameter and divide by 2. So r is equal to 25 centimeters. So the volume is equal to 4/3 times 3.14 times 25 cubed. So if I grab my calculator, I'm going to do 4/3 times 3.14 times 25, and to cube it, I'm going to have to use the caret button, and to the 3rd power. And I will get the volume here is 65,416.67 cubic centimeters. Now the reason I did 0.67 is if you see 0.66, so if I want to round to the 2nd decimal place, I'll look at the 3rd decimal place. If it's 5 or greater, I'm going to round up. 6 is 5 or greater, so I round it up. And that is the volume of spheres.